Witness the forces that engineer our planet's greatest spectacles. In this episode of Unreal Earth, we decode the survival instincts driving the massive Serengeti migration, the ancient biology fueling the giant sequoia trees, and the geological drama cradling the mirror-like waters of Hallstatt. We go beyond the view to explain why these places exist. If you are ready to see the world differently, hit that subscribe button and join the expedition. Walking into the groves of the Sierra Nevada mountains in California is like stepping back into the Jurassic period. These are not just trees. They are the largest living things by volume on the planet. To understand their scale, you must realize that some of these giants, like the General Sherman, have been silently growing since the height of the Roman Empire. Their existence is a biological paradox. They are born from destruction. These trees rely on forest fires to survive. Their massive, spongy red bark, up to 3 feet thick, acts as a fireproof shield, while the heat is required to open their cones and release seeds onto the ash-enriched soil. The challenge is capturing the verticality. You are looking at a landscape where the canopy is so high, it creates its own microclimate. The visual contrast is striking. The vibrant cinnamon red trunks standing against deep winter snow or summer ferns. You are standing among living skyscrapers that have weathered storms, fires, and history for 3,000 years. Along the coast of the English Channel, the Seven Sisters present a dazzling vertical barrier that looks almost artificial in its perfection. These undulating cliffs are composed of pure chalk, a soft white limestone formed during the late Cretaceous period. It is mind-bending to realize that this massive wall is built entirely from the fossilized remains of microscopic marine algae called coccolithophores, which accumulated on the seabed over millions of years when this area was submerged under a tropical ocean. Unlike the famous white cliffs of Dover, which are slowly becoming weathered and green, the Seven Sisters remain blindingly white because they are actively eroding. The relentless pounding of the sea shears off sections of the face, constantly revealing fresh, unblemished rock. Visually, this creates one of nature's most striking color palettes. The rolling green carpet of the South Downs, abruptly severed by a sheer drop of brilliant white, plunging into the churning blue sea below. Hallstatt looks like a fairy tale, but its existence is defined by harsh geological geometry. Squeezed onto a narrow ledge between the precipitous Dachstein Mountains and the Hallstatter Sea, this village is a testament to the value of salt. The mountains behind are filled with marine evaporites, salt deposits left by a prehistoric ocean and thrust upwards by tectonic collisions. This white gold is why humans clung to this hostile, vertical terrain for 7,000 years. The lake itself is a glacial creation, a deep trough carved by ice sheets that melted to create the dark, mirror-like water you see today. Visually, the scene is a masterclass in reflection and scale. Because the valley is so narrow and the water so still, the pastel houses and the looming grey limestone peaks are perfectly doubled in the lake surface. You are viewing a landscape where the mountains don't just surround the water, they seem to be holding the village in a stone embrace, creating a scene of absolute, silent symmetry. Across the endless plains of Tanzania and Kenya, the earth literally trembles under the weight of the largest terrestrial mammal migration on the planet. This is not a random wander, it is an endless, clockwise survival circuit driven by a single, powerful force, the rains. Over 2 million wildebeest, zebras and gazelles are biologically encoded to chase the seasonal storm clouds in pursuit of mineral-rich grasses. For the documentary lens, the visual climax of this journey is the perilous river crossings at the Mara. Here, the drive for sustenance collides with the raw terror of crocodile-infested waters. You are witnessing a chaotic, dusty spectacle where life and death hang in a delicate balance. This mass movement does more than feed predators. The grazing and droppings actually regenerate the soil, making the migration the true architect of the Serengeti ecosystem. The landscape surrounding the Li River in China is so surreal it is often compared to a traditional ink painting brought to life. Geologically, this is the world's premier example of karst topography. These thousands of limestone peaks, jutting abruptly from the flat rice paddies like green-covered teeth, began as an ancient seabed over 300 million years ago. Massive tectonic uplift exposed this limestone floor, and for eons, acidic monsoon rains have dissolved the softer rock, carving out deep grottos and leaving behind these resilient, jagged pinnacles. Visually, the Li River offers a study in serenity and scale. The water acts as a jade-green mirror, doubling the height of the mountains in its reflection. The scene is most atmospheric during the rainy season, when low-hanging clouds weave through the peaks. You are witnessing a battle between stone and mortar, where the water has gently sculpted the earth into a maze of stone towers. Halong Bay presents a seascape that feels mythical, fitting for its name, which translates to descending dragon. But the sculptor here isn't a beast, it is time and chemistry. This is the world's most spectacular example of marine-invaded karst topography. Much like the Lee River, these 1,600 towering limestone pillars were once part of a solid, continuous plateau. Over 1,500 million years, tropical downpours dissolved the soft rock into deep valleys. When the last ice age ended and global sea levels rose, the ocean flooded these lowlands, isolating the peaks and turning mountains into islands. For the lens, the result is a hypnotic, high-contrast maze. Vertical cliffs draped in jungle vegetation rise abruptly from calm, emerald green waters. The erosion is still active, hiding vast grottos and hollow caves inside the pillars that can only be accessed by boat. It is a geological fortress where the mountains don't just touch the sky, they appear to float on the ocean. In the western outskirts of Kyoto, the world transforms into a cage of filtered green light. This is the Arashiyama Bamboo Grove. But despite its height, this is not a forest of trees. It is a field of grass. You are looking at Moso bamboo, a species capable of growing nearly a meter in a single day. Beneath the walking path, a dense, aggressive network of rhizome roots knots the earth together, creating a foundation so stable that locals were traditionally told to run into the groves during earthquakes for safety. Visually, Arashiyama is a study in vertical geometry. The towering stalks crowd out the sky, creating a tunnel effect where sunlight fights to reach the ground. A phenomenon the Japanese call komorebi. The experience is also auditory. As the wind passes through the hollow stems and rustling leaves, it creates a specific soundscape that the Japanese government has officially designated as a protected national treasure. You are walking through a living cathedral that is constantly growing. In the frozen heart of the Reykjanes Peninsula, the Blue Lagoon presents a paradox. It is one of Iceland's most famous wonders, yet it was born from an industrial accident. This is not a traditional hot spring, but a beautiful mistake, created when runoff water from the nearby Svartsengi geothermal power plant was released into a porous lava field. The water, superheated by magma deep underground, is inextricably rich in silica. As it cooled, the silica precipitated into a white, clay-like mud that sealed the lava rock, trapping the water in these neon-bright pools. Visually, the scene is alien. You are looking at water that appears to glow a milky, electric blue, a trick of physics caused by suspended silica particles scattering sunlight. Surrounded by jagged fields of jet-black volcanic rock and creeping green moss, the steam-shrouded lagoon feels like a bathhouse on the edge of the world, powered by the terrifying heat beneath your feet. The Amalfi Coast defies the standard definition of a shoreline, presenting instead a vertical interface where the Laterri Mountains crash abruptly into the Tyrrhenian Sea. This dramatic topography is the result of intense tectonic uplift, combined with the erosion of sedimentary limestone. What looks like a static paradise is actually a rugged karst landscape, riddled with deep ravines, underground caverns, and sea grottos carved by water dissolving the porous rock over millennia. For the viewer, the visual impact comes from this extreme verticality. The cliffs rise thousands of feet straight from the water, creating a dizzying perspective that few other coastlines can match. While the pastel villages clinging to the rock face are famous, the true natural spectacle is the terrace geology itself. You are seeing a landscape where the earth didn't just meet the ocean. It fell into it, creating a jagged, sun-drenched amphitheater of grey limestone, lush scrub, and deep indigo water. Straddling the political fault line between Vietnam and China, the Ban Duc De Tien Falls offers a spectacle of fluid architecture. This is not a single sheer drop, but a classic example of a nick point in a karst river system. Here, the Quy Son River flows over a bed of limestone that has fractured into distinct shelves. As the water seeks the path of least resistance, it splits into countless streams, cascading over these calcified terraces in a thunderous, multi-tiered display. Visually, the scene is defined by its vibrancy. The water is a distinct, opaque jade. Green, a result of suspended calcium carbonate, which contrasts sharply against the pristine white foam, and the surrounding amphitheater of bamboo groves and jutting limestone peaks. Whether viewed from a bamboo raft or the riverbank, you are witnessing the raw power of a river sawing its way through the skeleton of the continent to create the fourth largest border waterfall in the world. High in the Cordilleras of the Philippines, the mountains appear to have been chiseled into a giant stairway to the sky. These are the Banaue Rice Terraces, but unlike the other wonders we've seen, this view is a collaboration between nature and 2,000 years of human labor. The indigenous ancestors didn't fight the geology, they contoured it. Working with primitive tools, they carved these steep slopes into thousands of mud-walled paddies that follow the mountain's natural curves. The engineering here is a mastery of hydraulics. An ancient irrigation system harnesses water from the rainforest above, filtering it down through the terraces using gravity alone. Visually, the result is a dizzying vertical landscape of vibrant emerald green. You are looking at a living artifact, a testament to how humanity can modify the earth not to conquer it, but to survive in harmony with its steepest edges. Tulum offers a rare collision where ancient history meets a geological masterpiece. While most Mayan cities are swallowed by deep jungle, Tulum stands defiantly on a 12-meter limestone bluff overlooking the Caribbean Sea. This specific positioning isn't accidental. The cliff is part of the massive Yucatan limestone shelf that abruptly terminates here, creating a natural fortress protected by the second-largest barrier reef in the world just offshore. Visually, this is one of the most high-contrast scenes in the Americas. You have the weathered grey stone of the Castillo Temple set against the shocking vibrancy of the ocean. That electric turquoise color is a phenomenon caused by the tropical sun hitting the shallow white limestone sand on the ocean floor, reflecting light back through the water column. Known originally as Zama, or City of Dawn, this site was built to face the sunrise. You are witnessing a landscape where a civilization used the dramatic geology of the coastline to frame their worship of the sun. Stepping onto the Isle of Skye is like walking into a geological battlefield where the earth is still settling. Located in the Scottish Highlands, this landscape is defined by the Trotternish Ridge, which is actually the result of massive ancient landslides, the largest found anywhere in Britain. What you are seeing in detail is a dramatic layering of volcanic basalt resting heavily on weaker sedimentary rock. Eventually, the weight caused the earth to fracture and slide seaward. This process created the iconic Old Man of Storr, a jagged pinnacle of rock left standing like a sentinel while the cliffs around it collapsed. The visual experience here is one of high contrast. Velvet green mosses clinging to sharp, black volcanic rock, often shrouded in the mist that gave Skye its Norse name, the Cloud Island. It is a rugged testament to the sheer power of gravity and time. On the Pacific coast of British Columbia, the Great Bear Rainforest represents a biological rarity. It is the largest intact tract of coastal temperate rainforest left on Earth. But this lush green cathedral is powered by a surprising source: the ocean. Scientists often refer to this as the salmon forest. During annual spawning runs, bears and wolves drag countless salmon from the rivers into the woods. As the leftovers decompose, they release marine nitrogen into the soil, acting as a super fertilizer that allows these ancient red cedars and Sitka spruce to grow to skyscraper heights. For the lens, this is a world of absolute saturation. Every square inch is draped in hanging mosses, ferns, and the heavy mist that clings to the fjord-like inlets. It is also the only place in the world where you can spot the spirit bear, a rare, white-furred black bear that creates a ghostly high-contrast visual as it moves through the dark emerald undergrowth. You are witnessing a cycle where the ocean literally feeds the forest. In southwestern Turkey, a mountain appears to be covered in snow, even in the blistering heat of summer. This is Pamukkale, fittingly translated as the Cotton Castle. But this surreal landscape isn't formed by ice. It is a masterpiece of sedimentary rock known as travertine. Deep beneath the surface, thermal springs become supercharged with dissolved calcium carbonate. As this mineral-rich water breaches the surface and cascades down the cliffside, it rapidly cools and releases carbon dioxide. This chemical reaction causes the calcium to precipitate and harden, layer by microscopic layer, building these gleaming white terraces over millennia. The contrast is absolute. Blinding white limestone cliffs holding tiered pools of vibrant turquoise thermal water. It creates a natural infinity pool effect that defies visual logic, especially at sunset when the white rock reflects the changing sky. You are looking at geology in motion. A frozen cascade created not by cold, but by the heat of the earth.